Let's talk about the commutative and associative properties of multiplication. I'm combining them together in one video to try to move things along. In the commutative property of multiplication, the way we usually see it in the book is it looks something like this. A times B equals B times A, and that doesn't mean a whole lot to us. And by the way, it doesn't tell the whole picture. It turns out for the commutative property of multiplication, and by the way, again, I'm focusing on the commutative right now. We'll do associative in a minute. It turns out that with the commutative property, you could have a whole bunch of things multiplied together, and then you can just mix them up any way you want. And if you do, you're still going to get the same result, the same product. So any of these results, any of these products will get us the same number. And you don't have to take my word for it. You can try it for yourself. Let's go ahead and see what happens if, what if we put some numbers in there, like 2 times 3 times 4. And then let's just mix them up. 4 times 3 times 2. 3 times 4 times 2. I bet you if you multiply them out, I bet you get the same result any of those ways. Now, that's basically the commutative property of multiplication, is when I multiply things together, it doesn't matter which order I multiply them, I will get the same product. And that's true whether I have numbers or whether I have variables. Let's take a look at the associative property of multiplication. So this next thing here is the associative property. And again, I'm just going to give you a quick overview of exactly what's involved here. With the associative property of multiplication, we say if I have A times B times C in parentheses, that should be equal to A times B in parentheses times C. Now again, it's what this thing is trying to tell us is not exactly what we see. What the rule is trying to say to us is that no matter how we group things that are multiplied together, we'll get the same product. So the associative property is all about grouping. So I'm going to go ahead and make that note, and you should add it to your notes as well. People think that it has to do with parentheses, and that you could have commutative property where there's parentheses. But associative means we regroup things. Notice how the B and C are grouped together here and the A and B are grouped together here. That's different grouping. Now, the tricky part is that these two things are equal. And again, that's a bit of a stretch for us to believe that if I regroup, will I get the same result. So let's try 3 times 4 times 5. And why don't you try and see what happens if we multiply 3 times 4 and then multiply that times 5. Again, hopefully you see that it doesn't matter how we group these guys multiplied together, we get the same product regardless. And what that means is that the statement on the left side of the equal sign is equivalent to the statement on the right side of the equal sign. That'll come in handy later on when we're working on algebra. And in fact, I'm going to show you an example of some algebra that we'll use later that's based on the commutative and associative property. And these are some really good reasons why we need to know these. So the next thing I want to talk about is an algebraic application of commutative and associative properties of multiplication. But before I do that, I want to make sure that we all agree on how to use powers. So take a look at this. If I say to you 5 squared, I'm hoping that you realize that that means 5 times 5. Now I know some of you think when you see 5 squared you think 25, but you're going to have to be careful. You're going to have to change the way you think about these powers, because when we're working with algebra, you have to understand that that power of 2 means 5 times itself. It's really important that you get that in your mind, as opposed to just 5 squared is 25. Now, in this case, it's true, 5 times 5 equals 25, but the main thing is 5 squared equals 5 times 5. And the definition of a power is that it will tell you how many times you will multiply something times itself. That's really important for you to know. Let's go ahead and let's take a look at another variation of this. What if we have something like 2 cubed? Again, I'm hoping that you realize what that means. Why don't you take a minute and try to write that down, and then I'll write it down and we'll see if we agree with each other. All right, here I go. It's going to be 2 times 2 times 2. In other words, I'm just multiplying 2 times itself 3 times. That'll get me a total of 8. 2 times 2 is 4, and times 2 is 8. Now, some of us look at 2 cubed, and the first thing that comes to our mind is 6, and the reason why is because we're not really thinking about the definition of the power. The power means 2 times itself 3 times. Now, let's take a look at an actual application of algebra that involves commutative and associative properties of multiplication when there's a power. So here we go. Here's our first example. And what we're going to look at is what happens when you have something like 3x in parentheses squared. Now later on we'll learn about how to work with this in a section where we talk about properties of exponents. But it's really good if you understand what properties allow us to do what I'm about to show you, and that's the commutative and associative properties. First thing, I'm going to remind you that when you see 3x in parentheses squared, it means 3x times 3x. That's what it means, okay? And we get that from the definition of what a power is. Now, the next thing is what happens when we, well, we'd like to actually multiply these two things together. And one trick that we'll use is we'll throw away the parentheses. And we can do that because of the virtue of the associative property. The associative property says that as long as things are being multiplied together, we can regroup them any way that we want. And that means we don't have to have any groupings at all. And so this just gets us 3x times 3x. And we'll write down that that is by virtue of the associative property. Again, I'd like to get you guys in the mindset of when you do a step in simplifying an expression or solving an equation, you should know why is it legal that I'm allowed to do the particular step. The next thing we'll do is we'll put the 3's next to each other, we'll move them around, and we'll put the x's next to each other. And again, I'm kind of hoping that you realize what we can use to justify that step, and it is the commutative property. It says that we're allowed to move things around and we will still get the same product. So this statement here should be equivalent to this statement here because of the commutative property. And then finally, we will go ahead and we will multiply the 3 times the 3. We get 9. X times x, that's x squared. And finally, we can box that. So there's our result. And let's go ahead and take a look at another example. As long as we're doing commutative and associative property and we're looking at more advanced applications, I thought it might not be a bad idea to throw in what happens with negative numbers. So what is the deal if we have something like negative 3x in parentheses squared? Well, when we have negative 3x in parentheses squared, again, we will, by the definition of a power, we will go ahead and we will multiply negative 3x times negative 3x. And because of the associative property, we are allowed to just throw away those parentheses. So we get negative 3 times x times negative 3 times x, and then let's go ahead and we'll move things around. First let's state what allowed us to do that. That was the associative property. It allows us to just throw away those parentheses, and then let's go ahead and we'll move things around. So it's negative 3 times negative 3 times x, and that we can justify. We were allowed to do that by the commutative property. And then let's go ahead and multiply stuff together. So we will go ahead and do negative 3 times negative 3, that's positive 9. X times x, that's x squared. And we've completed yet another wonderful example, and we can box our answer. Let's try another one with a negative sign. If you want, you can pause and finish copying this, and then we'll try another one with negative signs. So if you thought the last example was easy and straightforward, let me throw a monkey wrench into your spokes here. Maybe. Let's try this one, negative 2x to the third power. Now for many people, as soon as we see negative 2x to the third power, what happens is many people associate that third power with any power or even being squared, and they say, oh, that negative sign is going to become a positive. Let's see what really happens. So we're going to go negative 2x in parentheses times negative 2x times negative 2x in parentheses. And then we'll go ahead and we'll use the associative property to throw away all those parentheses. So we can now write this out as negative 2 times x times negative 2 times x times negative 2 times x. And over here we really should write associative property. And then next we will then use the commutative property to move stuff all around. And when we do, we'll get negative 2 times negative 2 times negative 2 times x times x times x. And if you recall correctly from previous math classes, hopefully you're coming to the conclusion that negative 2 times negative 2 times negative 2 is negative 8, not positive. And then x times x times x still gets us x cubed. So the result that we get here is negative 8x cubed. So just because you have a power doesn't mean that this negative sign becomes positive. All right, so there's the commutative and associative properties of multiplication. And that is, now you've seen some good examples that we'll use later on with algebra. Now, before we leave this video, I want to remind you, there was something I meant to mention earlier on. It'd be nice if you could add to your notes that with the associative property of multiplication, just like we said for the associative property of addition, that it just means you change the grouping. And so that means that you can throw away the parentheses as well as change the location of the parentheses. That's one thing that we'll use again and again. Now, you cannot use the associative property to throw away the parentheses if you have something like this. If we have 3 times 4 plus 5, well, there's not all multiplication or all addition here. So here we cannot just throw away the parentheses. But as long as we have all multiplication or all addition, then the associative property allows us to just throw away the parentheses. Again, this kind of idea will come in handy later. And please make sure that you do not believe that here you can do this. This is absolutely not allowed. It just doesn't work. And in fact, we'll talk about this another time. This is called the distributive property.